in my YouTube video channel of Engineering Graphics and Design subject. Myself Aarti Patel from LJ Institute of Engineering and Technology. This is 8th session of Engineering Curves chapter. In this session, we are going to learn cycloidal curves which are epicycloid and hypocycloid. First, let us understand epicycloid. What is epicycloid? It is a locus of point on the circumference of rolling circle or generator which roll without slipping or sliding outside the another circle or directing circle. Now, in cycloid curve, director is in form of straight line, and in epi and hypocycloid, the director is in form of circle. Here you can see this is epicycloid, which is generated by a point on the circumference of rolling circle which roll without slipping or sliding outside the directing circle. Here 3 revolution given outside the directing circle of this rolling circle. So this is epicycloid for one revolution. Now there are two types of epicycloid, inferior epitrochoid and superior epitrochoid. What is inferior epitrochoid? It is a locus of point inside the circumference of rolling circle or generator which rolls without slipping or sliding outside the another circle or directing circle. Next, what is superior trochoid? It is a locus of a point P outside the circumference of rolling circle or generator which rolls without slipping or sliding outside the another circle or directing circle. Now, the fundamental of inferior and superior epitrochoid is similar to the fundamental of inferior trochoid and superior trochoid. Next, let us solve the example of epicycloid curve. A circle of 50 mm diameter rolls on another circle of 150 mm diameter outside it. Trace the locus of a point on the circumference of the rolling circle for one complete revolution. Name the curve. First, list out given data. Small r is equal to radius of rolling circle is equal to 25 mm. Capital R is equal to radius of directing circle is equal to 75 mm. Answer, name of the curve is equal to epicycloid because as per given data, rolling circle roll outside the another circle, so it is a epicycloid. First, draw directing circle arc. Take radius for directing circle arc 75 mm. Next, draw rolling circle outside the directing circle. Take radius of rolling circle is equal to 25 mm. Now, for one complete revolution of rolling circle outside the directing circle, some theta angle use of directing circle. So, first find out theta angle of directing circle. R theta is equal to 2 pi r. 2 pi r is the circumference area of rolling circle which covered by directing circle. Because rolling circle roll outside the directing circle for complete one revolution. So theta is equal to 2 pi small r divided by capital R is equal to, put the value of 2 pi in form of angle is equal to 360 degree. The value of small r is equal to 25 and the value of capital R is equal to 75 mm. So angle theta is equal to 120 degree. So next fix theta angle of directing circle from this radial line, which is cover 2 pi r or pi d length of circumference area of rolling circle. Next, divide this rolling circle into equal 8 parts at 45 degree angle. Here, rolling circle roll in clockwise direction outside the directing circle. So, mark division point of rolling circle in anti-clockwise direction. Next, divide this theta degree angle into equal 8 parts because number of division of rolling circle is taken 8. Next, draw arc passing through all division points of rolling circle and which is parallel to directing circle arc. For that, take center O and draw arc passing through 1 and 7 point. Next, draw arc passing through 2 and 6 point. Next, draw arc passing through 5 and 3 point. And last, draw arc passing through 4 point. At last, draw arc passing through center point of rolling circle. Locate here last position of rolling circle. Next, mark center point of rolling circle on this center arc. Locate C0, C1, C2, C3, C4, C5, C6, C7 and C8 center point on this radial division line. Now, initial locus point is at contact point of rolling and directing circle. For remaining locus point, take center C1, radius is equal to rolling circle and cut arc on 1 number arc of rolling circle. Next, take center C2, radius is equal to rolling circle and cut arc on 2 number arc of rolling circle. Similarly, cut arc from C3, C4, C5, C6, C7 and C8 center of rolling circle on particular number arc of rolling circle. Mark here locus point as P1, P2, P3, P4, P5, P6, P7 and P8. Join this all locus point freehandly in form of curve. So, this is the epicycloid. Next, let us understand hypocycloid. What is hypocycloid? It is a locus of point on the circumference of rolling circle or generator which roll without slipping or sliding inside the another circle or directing circle. Here you can see this is hypocycloid which is generated by rolling circle which roll inside the directing circle for complete one revolution. Here 3 revolution of rolling circle is given inside this directing circle. So this is the hypocycloid for one revolution of rolling circle inside the directing circle. Next, let us understand types of hypocycloid. There are 2 types of hypocycloid, inferior hypotrochoid and superior hypotrochoid. The fundamental of inferior and superior are common for cycloid, epicycloid and hypocycloid. Now, what is inferior hypotrochoid? It is a locus of point inside the circumference of rolling circle or generator which rolls without slipping or sliding inside the another circle or directing circle. Next, what is superior hypotrochoid? It is a locus of point outside the circumference of rolling circle or generator which rolls without slipping or sliding inside the another circle or directing circle. Next, let us solve example of hypocycloid curve. A circle of 50 mm diameter rolls on another circle of 150 mm diameter. Inside it, trace the locus of a point on the circumference of the rolling circle for one complete revolution. First, list out given data. Small r, radius of rolling circle, is equal to 25 mm. Capital R, radius of directing circle, is equal to 75 mm. So first draw 75 mm radius directing circle arc. Next draw rolling circle inside the directing circle. Take center of rolling circle 25 mm inside the directing circle. Next, find out theta for directing circle. Similarly, as per hypocycloid. So theta is equal to 120 degree. Next, draw 120 degree angle line for directing circle. So the arc length of this directing circle is equal to 2 pi r or pi d. Next, divide this rolling circle into equal 8 parts at 45 degree angle. Here, rolling circle roll in anti-clockwise direction. So, mark the division point of this rolling circle in clockwise direction. Next, divide theta degree angle of directing circle into equal 8 parts. Next, draw arc parallel to directing circle passing through all division points of rolling circle. For that, take center is equal to O. So first draw arc passing through 1 and 7 point of rolling circle. Next, draw arc passing through 2 and 6 point of rolling circle. Next, draw arc passing through 5 and 3 points of rolling circle. And at last, draw arc passing through 4 point of rolling circle. Also draw center arc of rolling circle and mark here center points C0, C1, C2, C3, C4, C5, C6, C7, C8 on this radial line which is intersect at one point on this center arc. Next, locate last position of rolling circle from C8 center. Now for locus point, initial locus point of hypocycloid is at contact point of directing and rolling circle. For remaining point, locus point, take center C1, radius is equal to rolling circle and cut arc on 1 number arc of rolling circle and mark here locus point P1. Next, take C2 center, radius is equal to rolling circle and cut arc on 2 number arc of rolling circle and mark here P2 locus point. Similarly, take center C3 and cut arc on 3 number arc of rolling circle and mark here P3 locus point. Similarly, find out P4, P5, P6, P7 and P8 locus point from C4, C5, C6, C7 and C8 center of rolling circle. Next, connect all these locus point freehandly in form of curve. Then we will get hypocycloid. One thing always remember, if the radius of rolling is half the radius of directing circle, then the hypocycloid is a straight line. So this is the end of this session. See you soon in next coming video lecture. Thank you.